Just checking number 4. So, what do we know? So we're going to think, show, and tell. So we're going to think about this. What do we know? Well, we know that the mean and standard deviation, the mean is symbolized by the Greek letter mu, lowercase letter. For this population is 184. For Dutch men, the mean is 184 centimeters. Standard deviation, symbolized by a lowercase Greek s called sigma, is 8 centimeters. And we're told that the distribution of Dutch men is approximately normal. So we symbolically represent the distribution of Dutch men as 184, 8, with the capital italic N and then the 148, the mean and the standard deviation in parentheses. Now, what does this mean? Well, here's what it means. We draw a bell-shaped curve, put the middle in, and then we make 3 evenly spaced measurements along the x-axis, along the horizontal axis. Okay? So, and then let's extend these into partitions, 3 partitions to either side of the median, the mean, the center of the distribution, which is 184. Now, the standard deviation is the measure for how usual or unusual a data point is. So one standard deviation is 8. So the measurement, the height measurement for one standard deviation away from the mean, to the right of the mean, is 192. Now, for 2 standard deviations, this is 0 standard deviations here. Here's 1 standard deviation. 2 is 200. And 3 standard deviations is 208. Okay, now -1 standard deviations, -2, and -3, those are 3 to the left. The height of Dutch men who are 1 standard deviation to the left of the mean is 176 centimeters. And 2 standard deviations would be, I believe, 168. And 3 standard deviations would be 160. Okay, so we measured out the standard deviations. What does it mean when we're saying it is a normal distribution? Well, it means that 34% of the population of the Dutch men is between 184 centimeters and 192 centimeters approximately. And 34% of the heights of the Dutch men are between 176 centimeters and 184 centimeters. In other words, between -1 standard deviations and 0 standard deviations from the mean. Which means that 68% of the Dutch men are between 176 and 192 centimeters tall. Or they are 68% of the Dutch men are between -1 and +1 standard deviations from the mean. So 68%. Now, if we go to the next standard deviation, in the partition between -1 and -2 is 13.5%. And between 1 and 2, the partition between 1 standard deviation and 2 standard deviations is 13.5%. So 13.5% of the Dutch male population is between 168 and 176 centimeters. And 13.5% is between, approximately, this is all approximate, is between 192 and 200 centimeters tall. So if you add up all 4 of these partitions, that is from -2 standard deviations to +2 standard deviations, you're going to have 13.5 plus 13.5, which is 27, plus 68, 95%. So 95% approximately of the Dutch men are between 168 centimeters tall and 200 centimeters tall, and or between approximately -2 standard deviations and +2 standard deviations. And this is the normal distribution and how it's applied to the population of Dutch men. Now we can go further. We extend the line at 3 standard deviations. Between 2 standard deviations and 3 standard deviations is 2.35%. Pretty small. So between 2 and 3 is 2.35%. Notice that I did not draw this to scale. Okay, so 99.7% of the population of Dutch men is between 160 centimeters, 3 standard deviations to the left, and 208 centimeters tall, 3 standard deviations to the right. Or we would always say that 99.7% of a normal distribution is approximately between -3 and +3 standard deviations. And we call this the 99.7, 99-68% rule. 68% of a normal population is approximately between -1 and +1 standard deviations. 95% is approximately between -2 and +2, or in this case, between 168 and 200 centimeters tall for the population of Dutch men. And 99.7% of a normal distribution is approximately between -3 and +3 standard deviations. In the case of the Dutch men, between 160 centimeters and 208 centimeters tall. Okay, now, where are we with all of this? So this is what we know. Since we are told that it's normal. So with a normal distribution, we know that the distribution of heights for Dutch men distributes approximately like this. It's always going to be approximate. All right. Now we're asked, the question is, if a normal model is appropriate, what percentage of all Dutch men will be over 2 meters tall? That's 200 centimeters, or 6 feet 6 inches. Okay. Well, now instead of messing with this, I'm going to draw another picture. And this is what you'll be doing most often. You won't be drawing that whole thing. Okay, so let's put 184 in the middle. That's the mean. And here we're going to put 200. This is our data value of interest. Now we want to calculate the z-scores. And this is something you're always going to be doing. Z equals y minus mu, standing for mean, or y bar if we're talking about a sample, mu if we're talking about a population, y bar if we're talking about a sample. Y minus mu over sigma, or we would say standard deviation of the sample, S sub x. But in this case we're going to say sigma because we're talking about a population. So that will give us the number of standard deviations that y is from the mean. So that's going to equal 200 minus 184 divided by 8, which is 2. So 200, and you can see, here's 200 right here. It's 2 standard deviations. I forgot to put in. And all of the standard deviations beyond 2.35% is 0.15% to the left and 0.15% to the right. So that's the rest of the tail beyond 3 standard deviations is simply 15/100ths of 1%. Okay, not very much. The tails are asymptotes. They approach zero but never reach them. So the number of standard deviations under the curve can theoretically go on to infinity. But we don't care about that, okay? We don't care about theoretical. All right. So the z-score is 2. So we want to know the entire area of the curve to the right of 200. So how much area of the curve is 2 standard deviations or more away from the mean? Well, we know that from our picture. 2.35 plus 0.15. So that would be 2.5%. That's according to the numbers that were given here. If we did this with our calculator, we would get a slightly, and by slightly I mean off by 100th or 2, different answer. Okay? We'll talk about doing it with the calculator in a moment. All right. So we have talked about what do we know. This is all the stuff we knew. This is what we're told. What do we want to know? Well, we talked about that. The percent that's greater than 200, equal to or greater than 200%. I'm sorry, 200 centimeters. What am I saying? 200%. Okay. All right, and we found that it's 2.5%. And the preconditions, were they satisfied? Well, there were no preconditions for us to worry about because we're told in the problem that the normal distribution applies. Since we're told that the distribution of adult Dutch men is approximately normal, our condition is satisfied, we can go ahead and apply the normal model to answering our question to find out what we want to know. Okay, and so now we've gotten our answer, and so we're going to write our answer. Okay, approximately, it's the word you will begin every answer. Approximately 2.5% of Dutch men are equal to or taller than 200 centimeters. That's that. You've answered the question. Okay. Now, that's it. I'm going to ask a different question. I'm going to make it a little bit, in some ways, a little bit harder, or not really harder, just different, but more like what you're going to do all year. Okay? So I'm going to ask a different question. And let's start over again. Okay? Different question. Assuming an approximately normal distribution, for Dutch men, what percentage are 203 centimeters taller or greater? Actually, that's going to be really, let's make it 195. Are 195 centimeters taller or greater? Okay, so this is what we want to know. What percentage are 195 centimeters taller or greater? What do we know? Well, we know that the mean and the standard deviation are 1 under 4 and 8, and we're told that the distribution is approximately normal. So preconditions are satisfied. We can use the normal model to answer this question. So what do we know? We know the mean and standard deviation. Preconditions are satisfied. This is what we want to know. Okay, draw a picture. Put the mean in the middle, and the mean is 184. Okay. Put down your data element of interest. 195 centimeters. This is 184 centimeters. Now, we're going to just deal with the preconditions. We are told you must state this. The distribution is normal. You must write a sentence saying this. Even though it tells you it's normal, you must acknowledge it, so that I know that you know that it's normal, and then therefore you can use the normal functions on your calculator to answer this question. We are told the distribution is normal. So we use the normal distribution to answer the question. To answer the question. Okay? All right, so this is the thinking portion. Remember, think. Now you're going to do the work. Show z equals y minus mu. We're dealing with population, so we're using the Greek letters, over sigma, which equals 195 minus 184 over 8, which equals 11 over 8. Okay? Now, you can make this into a 1.375. You can make it a decimal if you want, or you can just leave it as a fraction. Why? Because your calculator is going to handle it for you. Okay, so the z equals 11 over 8. So at this point, there's no more calculations that you can do. This picture that we drew here of the normal model doesn't accommodate an eighth or 3/8 of a standard deviation. Okay, the yardstick is only good for 1 standard deviations, 2, 3, and there's the very convenient breaks. Okay, look for answers that you can handle that you can answer with this distribution, like this, say in multiple choice questions. Okay, but we're going to need the calculator and answer this. Okay, so here's what we want to know. We want to know what percentage is 195 centimeters or taller. This percentage right here. Okay, now we know that it's 1 3/8 standard deviations. Okay, so let's label this. Let's label this 11/8 right here. Okay, now we want to go from here all the way out many standard deviations. Okay, so let's say, I always say 99 just for the heck of it. Okay, we're using z-scores or standard deviations. This is the z. We want to go from z equals 11 over 8 to z equals 99. Okay? Now, if I was on the other side of the distribution, I'd be going from z equals 99 to negative 11 over 8 or whatever. Okay, but this is a positive number, so I'm going from 11 over 8 all the way to the right-hand side of the distribution. This will give me the percentage that is 195 centimeters or greater. And since I already have a z-score, I'm not going to use the data. I'm going to use the z-score to do the calculation. So I hit second, and then the virus key. Normal CDF is 2. Let me do that again. Second, and the virus key. Normal CDF is 2. Now the syntax is left-hand measurement, right-hand measurement. Now I'm doing z-scores, so I'm doing 11 over 8, comma 99. And you can put a fraction into your calculator, and it will be quite happy to deal with it. Okay, so 11 over 9, comma 99 is going to take me from this z-score, 11 over 9, out to 99 standard deviations to the right. I hit enter, and here's my percentage. Okay, so call this a probability that percent greater than or equal to z equals 11 over 8 is 11.08%. Okay, so about approximately 11% of the Dutch men, that's the area under the curve, this is all, this curve represents all the Dutch men, from the very shortest down here to the very tallest over here somewhere, okay? And what we're saying is about 11%, approximately 11%, is 195 centimeters or taller. Okay? And that's that. Now, just try to reproduce this one particular, like go through this, and here, you know what I'm going to do? Here, do this. What percent of Dutch men are, let's see, the mean is 184, 100 and, let's see, let's go to this thing, 170 centimeters tall or less. Or less. Now this is what we want to know. Now what we do know is the same. 180 approximately normal. Okay? Normal 184,8. That doesn't change. Okay? So we draw ourselves a picture. We put 184 in the middle. And now here we're going to put 170. So this is centimeters. And this is centimeters. Okay, now 170 centimeters tall or less. Okay, so we want this area under the curve right here. Okay, and this will take us from the Dutchmen who are 170 meters tall to the shortest members of the population way out here and to the left of the curve. Okay, here's where the shortest men are, the tallest men are over here somewhere. Okay, so Z equals Y minus mu, it's not a good looking mu, Y minus mu over sigma, which equals 170 minus 184 over 8, which equals negative 14 over 8, which equals negative 7 over 4, negative 1.75. Okay? It's a negative z-score. Why is it negative? Because it's to the left of the center. Okay? Z equals negative 1.75. And now we want to go from negative 1.75 to negative 99, to as far as we can go into the left. Okay? Now, understand that negative 99 is to the left of negative 1.75. Okay? Let me make sure I didn't screw up this calculation. 170 minus 184, that's negative 14 over 8, negative 7 over 4. Okay. So we're going to do normal CDF again. Second and vars, normal CDF 2. But now we're going to put in the left. We always put in the left-hand measurement first. So I'm going to put in negative 99. In other words, the measurement that gives me the left side of the tail, comma, negative 1.75. Close parenthesis, enter. And so this area of the curve is about 4%. So about 4% of the Dutchmen, approximately 4%, of Dutch men are 170 centimeters tall or less. And that's probably enough for right now.